Hi everybody, so today we're going to be discussing how to convert between degrees to radians and then from radians to degrees. That's the main topic for today, but before we do that I do want to discuss how we graph angles in a coordinate plane or angles in standard form. So there's two ways of approaching this, which is known as the positive angle measure, okay, which is this guy right here, our positive angle measure. And we're going to be discussing how to rotate that on a counterclockwise way. So counterclockwise is the opposite of the way a clock works. So something like this. Okay. As we go through these planes here, we're going to see that this would be at a 90 degrees, at 180 degrees, 270 degrees, and a 0, and also 360 degrees. Okay. Now, if we're discussing negative angle measures, that's going to be at a clockwise way. So clockwise would be the way a clock works, which would be going in this way. Now, typically, I like to see these angles starting off the same way at 0. Okay. But when moving this way, instead of this being 270 like it is on the counterclockwise way, we would see this as a negative 90. So this is negative 90, respectfully over here would be negative 180. And over here would be negative 270, with us remaining here at negative 360. Okay, we're going to do a couple of practice problems to clear this up, so hopefully that should help. So let's look at here. We've got our first problem at 75 degrees. More importantly, this is a positive 75 degrees. So the first thing that I want to do with you all is I want to make sure that we label our angles here. So we know this would be 90, 270, oh, sorry about that. This would not be 270. This would be at 180, 270, and 360. So when I'm graphing 75, I want to start here and I want to start moving up. Well, I'm going to stop right here because immediately I see that if I can't get past 90, and I'm not going to be like here in the middle, which should be 45. I'm going to be like right up here when we'd have this angle at 75 degrees. It doesn't go any further than that. Okay. Again, I couldn't pass the 90 because obviously 75 is less than 90. Okay. Let's try negative 160. So with negative 160, again, we're at the negative side, so we know that we're going to be going in a clockwise fashion. So when I'm labeling my angles here, I'm going to start here at 0. If I'm going clockwise, I'm going to go here at negative 90, negative 180, negative 270, and then we come back at negative 360. Well, negative 180, I know I'm going to be passing the 90, so I can bring my angle out somewhere here. Now, I have to ask myself, will I be smaller than negative 180? Well, negative 160 is not. We can't pass that up. So we know our angle has to be somewhere here. In between the negative 180 and the negative 90 lies negative 160. Okay? And we've got 430 degrees. More importantly, a positive 430 degrees, so we know this will be counterclockwise. Well, I'm going to label my angles here at 0, at 90, at 270. Oh, I did it again. This is going to be at 180, 270, and 360. So what's going to happen here is I'm going to come around. I know I'm bigger than 90. I'm bigger than 180. I'm bigger than 270. Oh, look at that. I'm also bigger than 360. Okay? So because I'm bigger than 360, I need to start a whole other revolution around. Okay? So I need to go to 430. Well, if I'm already at 360 and add another 90 to this, This would also be at about a 450, not about it, actually exactly 450. So if I'm looking for 430, I know that I've got to be somewhere between 360 and 450. So my angle would be here at 430 degrees. This is between 360 and 450. Okay? So now let's discuss radians, because I know radians is new for a lot of us. So radian is a unit of angle measure based on arc length. One radian is defined as the measure of an angle formed when the radius is equivalent to the length of the intercepted arc. Recall that the circumference of a circle is 2r pi. Therefore, 360 degrees in one full revolution is equivalent to 2 pi radians. So one full revolution, okay, is 2 pi radians. And 180 degrees is equivalent to pi radians. Okay. So let's start converting between radians and degrees. So we've got this formula here. Radians equals degrees times pi radians over 180. And when we're going from radians to degrees, okay, we'll take that radians and we're going to be multiplying that by 180 over pi radians. I know this sounds very confusing, so let's go ahead and jump into a couple of problems. So let's go ahead and convert from degrees to radians. So I have 30 degrees. The first thing that we want to do, step 1, okay, like we see here, is set up the problem. So my setup is this part right here. This is my step 1. So I'm going to take 30 degrees and I'm going to multiply it by pi. Okay, let's pause on the radians, we'll get there, and then we're going to divide that by 180. Okay, we're going to multiply the degrees by pi, okay, and then divide by 180. So what that essentially looks like is we're going to have 30 times pi is 30 pi, divided by 180. This is step 2. All I did was multiply across. Numerator with numerator, denominator with denominator. And my last step that we're going to be doing here is we need to simplify the fraction. Okay. Well, 30 and 180 are both divisible by 30, and we can divide this guy by 30. So my final step, well, 30 divided by 30 is just 1 pi over 180 divided by 30 is going to result as 6. So my final answer here would be pi over 6 radians. Okay. I know the step 1 was pretty easy, step 2 is pretty easy. What's going to be a little bit of time consuming for some of y'all is the simplifying. Okay, use your calculators to help that out, guys. There's no shame in that. Okay, let's do another problem here. Let's go ahead and look at number, this one here at the 150 degrees. So we're going to do step 1 where we set up the problem. So we're going to say 150 degrees times pi over 180. This is step 1. Step 2, okay, when we set up the problem, we're going to multiply this out. We're going to see that we have 150 pi over 180. Technically, we're done with the problem here, but we do want to simplify. When we're looking at what we can simplify this by, both numbers, 150 and 180, are divisible by 30 again. So when we simplify this out, well, 150 divided by 30 is 5 pi over 180 divided by 30 is going to be 6. And so we're left with 5 pi over 6 radians. Okay? And let's do one more together. So step 1, we're going to set up a problem. We're going to say negative 220 times pi over 180 We multiply across here. So we're going to get, for step 2, negative 220 pi over 180. We want to go ahead and simplify this out for step 3. Okay. Well, what are both of these numbers divisible by? They're both divisible by 20. So negative 220 divided by 20 is going to be negative 11 pi, can't forget that pi, divided by 180 divided by 20 is going to be 9 radians. And this is your solution. So again, this was going from degrees to radians. Again, we start with degrees, we finish with radians. Degrees to radians, degrees to radians. So now let's look at radians to degrees. So what's going to happen here is you've probably already noticed we're multiplying by the inverse of what we had before. So instead of multiplying by pi over radians, now we're going to be multiplying by 180 over pi, right? So we're going to follow all the same steps. Step 1, if you see here, is we want to set up the problem. So we're going to say 4 pi over 3 times 180 over pi. That's step 1. Step 2, we want to multiply across. Okay? So we multiply across with 4 times 180 is 720 pi over 3 pi. 4 times 180, and with pi, and 3 times pi. This is what we have here. And now we want to simplify. So step 3, simplify, that's our last step. Well, we know that pi divided by pi, those simplify out to 1. So we're left with 720 over 3. We put that in the calculator, we'll be left with 240 degrees. And that is your answer. Let's try another one. Let's look at this problem here. We're throwing a negative in there. Same steps, guys. So we're going to go ahead and set it up at negative 5 pi over 36 times 180 over pi. Let's go ahead and multiply across. Negative 5 times 180 is going to give us negative 900 pi over 36 pi. Our final step, when we simplify out, pi over pi simplifies out, so you're left with negative 900 divided by 36. Negative 900 divided by 36 is negative 25 degrees. And our last problem for the day today, we've got 7 pi over 40, 7 pi over 4, we're going to convert that to degrees. So step 1, we're going to go ahead and set up the problem at 7 pi over 4. We're going to multiply that by 180 over pi. Step 2, we're going to multiply this out with 7 times 180 is 1,260 pi divided by 4 pi. Okay, we multiply down here as well. And our last step, simplify this out. Pi over pi simplifies out to 1. So we're left with 1,260 divided by 4. And that simplifies down to 315 degrees. Okay. Guys, please take the time to look over these. Your assignment for the day is directly aligned to these questions as well. There's nothing different, nothing more, nothing less, nothing tricky. Please hop onto my office hours if you have any questions. I strongly recommend you do that before you answer or submit your assignment. Again, if you have any questions, please ask me during my office hours, and I'm more than happy to do more problems with you guys. You'll have a good day, and we'll talk to you later.